So same idea. We're going to do binomial theorem. But this time we're going to focus on essentially how Pascal calculates the numbers, what he uses, and it's called combination. So first thing you have is Pascal's formula. And you look at it, and it looks like something that you just pretty much want to memorize, because you're like, I'm not sure how on earth you would get something like this, right? It says the nth number is equal to two combinations where the nth number is one less, and then in the first one, the R number is one less, but in the second combination, the R number is the same. How does that help? And then, even more confusing, is when we apply it to a binomial, they've given us something that says the sum of all the values from R being at 0 all the way up to the nth value is equal to these combinations, and this is how you set each of them up. Looks confusing. But if you recall Pascal's triangle, what it's trying to do, and I didn't draw this the best, but it's actually just trying to relate a combination to each of these values. Okay? So for instance, let's say we're in row 3. Okay, oh, sorry, I lied. Let's say we're in row 4. Oops, wrong one. That is row 3. For us, at least. Remember, the first one doesn't really count because this is where our binomial starts, right? Where we have two terms. So that would be considered our exponent of 1. This would be our exponent of 2. So let's say it's exponent 3. I should have used different wording. We have 4 terms, right? Let's say I wanted the term, I needed the coefficient for the term, for the third term in here, okay? What this is saying is I can actually calculate this in our here's our first binomial. So this is our a plus b squared. This is to the power of 1, to the power of 2, and this one's to the power of 3. Each combination will start with our value of 3, okay? And we can calculate by actually putting this combination into a calculator, this value of 3. The combination is written as 3C2. And if you have a combination calculator, and I don't think this one actually has that on it. No. But if you have a combination calculator and actually you calculate this, I'm going to try it on that calculator right now. So it's 3C2.
3.
Yeah, exactly. And that's the exact value we had over here. That value is 3, okay? So let's say we're at the power of 5, and I need the, third term in, okay? Third term in looks like it's supposed to be the value of 10. Okay, well, the third term in the power of 5, this one's to the power of 4 there, and this one's to the power of 5. And you can tell because the combinations in that row will start with our value of 5. We wanted the third one in, which is this guy here. Well, let's see what that coefficient would actually be. Let's calculate it. So let's use that 5C2.
10.
Exactly. Okay, so if we're actually trying to find a specific coefficient very far down along this, we can use combinations much more accurately than we can use Pascal's, because with Pascal's triangle, we probably have to continue this. So if they told us they wanted us to the 20th exponent there, that's going to take us a really long time to build. But we know with the 20th exponent, we know we're going to have some combination, okay, so dot, 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 some combination of the 20th, and it just depends on how many values in it is, okay? So with that being said, let's say it's, the 8th term in. We can literally just calculate that without having to go through Pascal's triangle if it was the 8th term in. And how does that help us with setting up the expansion of a binomial, okay? I don't know why I went up and down, but so when we're expanding this, let's say it is to the 8th, right? Well, what we're going to do, our actual exponents will be identical. So let's say we are working with a and b, okay? Well, our very first exponent is going to be a to the 8 times b to the 0, so we don't put it in. And our combination is just going to be 8c0. It's going to be our first one in the list. Then when we add our numbers, our next combination, I'll do the combinations in red so you can see a bit of a difference here. Our next combination will be 8c1, so that'll be the coefficient. And then we just follow the same rule with our exponents, and I'll color those also. So that's a to the 8. So this one would be a to the 7, and what would our b value be?
B to the 1.
And that's it. We follow that identical process, but in terms of calculating the coefficient, it makes it actually very simple. We just use a combination instead of having to write all of Pascal's triangle out. Okay? That's the first part. That part makes sense?
Mm-hmm.
Yeah. Okay. Second part is, I have use this formula. What does this formula mean? Well, what they're telling you is actually how to calculate in Pascal's triangle the next value. Okay, so let's see if we can relate this. What this says, and let's take a value that's in here. We'll go to the third level, and let's say they're looking for, I'm actually going to go to the bottom here. So third level, I'm going to highlight it. So that's our power of 3. So let's say we're working with this level here. Okay, and just like the one we talked about here, they ask us in Pascal's formula to calculate 3C2 as our combination. Well, in Pascal's formula, it's C to the n minus 1, r minus 1, plus C to the n minus 1 to the r, right? Okay, let's see if we can actually calculate those values and make sense of what they're trying to ask us. Well, n minus 1, that's 3 minus 1, right? So we know both of these are going to be 2 combination something. The first one is r minus 1, so combination 1. And the second one is identical to r, right? So C2, 3C2. What it's saying is if we add these 2 combinations, we will get this third combination. Oh, okay, so let's actually take a look at that. In order to get the next combination in the list, we added 2C1 and 2C2 to get 3C2, which makes identical sense to, in Pascal's triangle, adding the 2 numbers up to get down there. They're just using actual combination values. Okay? So that's how we go about, or at least that's how you could relate Pascal's formula to the triangle use, and then that's how you can find specific values in binomial theorem form. So if they were asking you for a specific one, you can use a combination to find the coefficient value much quicker than you could going through Pascal's triangle once it gets very deep into it.
Yeah.
Does that make sense?
It makes sense, yeah.
Yeah, okay. So we have this value here, and they've asked us to find the numeric value. They want that coefficient we're talking about, so they're looking for some number. They've told us that we're working with a plus b to the 11th. Okay, so we're talking about the final answer in the end. We started with our triangle, and it went all the way down, and we're now at the 11th level. What would be the coefficient in front of this? Well, we are going to have to figure out what term this would be. Okay, now we know that in this, our very first term on the left will be a to the 11th and b to 0, right? So we must be counting down. If that's the first term, the second term must be a to the 10th, right? Third term, a to the 9th. And then we would follow that across. And as we're doing that, our b would be technically 0, b would be 1, b would be 2. So our b, that one probably will help us a little more through this, our b exponent will just be 1 under the term we're at. Does that idea make sense? That's counting through. So because our b exponent is 9, we're on the 10th term here. So we're looking for the coefficient, and we know the exponents will read a2 at that point and b9. Okay? Well, for our coefficient, we can use a combination to solve this very quickly. Because we're on the 11th level, we know our combination, like we said, will be 11. And because we are, how many terms in here? We're 10 terms in. The actual combination value, and I'll sneak back to the other page just to help make sense of that. The combination value is actually the same as the b exponent. For instance, in row 2, this would have originally read a2. That's how we would have started b0. That's our 0. The next one would read b at 1, just like that. And the next one would read b at 2. Okay? So that second value in the combination is the same as the exponent of b. So with that being said, because our exponent of b is 9, we're looking at a combination of 11c9. Do you want to calculate it with the calculator there? All we have to do is actually use this combination to solve that value.
55.
So your numeric value of that would be the number 55. Okay? So for instance, let's make up another question. Let's say they say, let's go to the 20th term, or 20th power. Okay? So a plus b to the 20th, middle term. Okay, middle term. They want us to find the middle term. Well, there's a couple things we can do to help solve this. First of all, we know the exponents as we go through our a's and b's. We know their actual powers are going to add up to our value of 20, right? So the middle term must mean they're identical, the exponents we're on. So we must be working with a 10 and b 10 to be the middle term, right? Now what we're looking for, though, is our coefficient as we go through. Well, again, it's a combination, and we know it goes to what level? So what is our first number in the combination going to be? It's going to be 20. We just got to figure out what term it is. And what did we say we could use to help us find out what term?
B.
Yeah. Is it the same as that, or is it a little different?
It's one more.
Well, the term number will be one more. So it would actually be the 11th term, which makes sense because how many terms are in this?
21.
21. All right. So we'd have the first term, and then we'd have the 21st term. So the middle term would be the 11th. So that helps us find out what number term it is. But in terms of the combination, it's actually identical to the exponent of b, like we said over here. The exponent of b was 9. Our combination second number was 9. So in this one, we'd have 20c 10 for our coefficient in front of it. So they asked us for that middle term, so we have to calculate 20c 10. And we know our exponents are going to be a to the 10th and b to the 10th, okay, because the middle term would have to add them both together. What would our combination value be? What would that coefficient be? You want to calculate it? Calculate on the computer is not that great.
184,756.
All right, 184,756. A to the 10th and b to the 10th would be your middle term. Now, just keep in mind, if it's an even value, you can get a middle term because we always go up one, right? So if it's 20, we know there's 21 terms. If it's 16, we know there's actually 17 terms. If it's an odd value, like a plus b to the 11th, well, there's technically 12 terms, which means we'd actually have two middle terms.
Yeah.
Remember, those coefficients would be identical like in Pascal's triangle. We'd get something like this here. Whoops. The 3 and the 3, or the 10 and the 10, right? And all that would be different would be the exponent values, okay? We can only really get middle terms when we're at an even value there. Okay, so let's see.